Okay, so guys, this is the part two of a just ended video I did about the gold market. And in this video, our goal is to find the results of the model and also see how we can create a boundary for this hypothesized particle that is traveling and the boundaries we expect these particles to travel in. We are expecting to create a subspace for this particle, and if we are able to do that, that means we may know how is expected to travel and the reaction we are expecting at a given point in time, right? So let's jump into the results of the model, right? Before we go, let's quickly refresh our memory. We said that we are going to find a best fit model that fits this cycle to this cycle, right? We we made that assumption, and we by far we have been right that this cycle is very similar to this cycle, and we have been able to make decent predictions following that assumption. And now we are trying to prove it by a mathematical model, right? So since we are saying they are similar, we are trying to fit them and see how it's generalized well, right? Later we will find out that it does not only fit this cycle, but if we include all other price time vectors, we will still be getting the same results, right? But we will keep it simple and use the similar cycle, which is guaranteed to give the best optimal results, right? So the idea is that when we are given an upward vector here, there is some transformation on this upward vector that creates a downward vector, right? And these vector additions creates the resultant vector here, which is the total distance traveled by a particle within a cycle, right? So in the first cycle, the total distance traveled by the particle. Second cycle, this is the total distance traveled by the particle. Third cycle, so within this cycle, the major cycle, we have three subcycles, and this is the same. This similar. We are hoping for similar expectation in this cycle, right? So we will be looking at the vectors, the upward vectors and the downward vectors, right? And we believe that there's a relationship. So we are trying to find that relationship. And when we find that relationship, we should be able to compute that if, assuming this section has not formed yet, right? If we input this upward vector to this point here, our model should give us a decent price time vector of the downward vector where we expect the particle to travel to conclude that cycle. So this is the major goal that we are trying to achieve, right? So let's jump right into it. Okay. Um, so this is the table here. So we have the first vector 188 by 188 is the days and is the change in price, and this is the magnitude, right? The vector magnitude. So this is the price time vector, and this is the magnitude. So this is the first. So the first one, two, three is the first cycle that we are trying to fit. and 1, 2, 3 is the last cycle we are trying to fit. So this is the upward vectors, right? But with the downward vectors, you realize that here is dash, because that is what we are trying to predict. So we only have the upward vector in the last cycle, but we don't know the extent of the downward vector. So by the least square model, we will fit this upward vectors and these downward vectors, and this resultant vectors, their addition, right? So that we can predict where we expect um, 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 the next downward, how the downward variable, and we can see that the results is that we are expecting in 183 days and minus 378 change in price, and the total magnitude is 420. This is the most important thing that we are looking here. This may be important but not all that important because it is not constant. But the most important thing is the 420, where the 420 is the magnitude, right? Is the magnitude. And with magnitude and how we are going to use it, we know that the magnitude may be constant, but this price and time may vary in an equal proportion to maintain the structure. We will understand it very shortly. So, as our predictions, as this prediction, we will want to know how it generalize with uh, other sets, right? First, we will consider the duration, right? We realize that with the duration, if we add the first 3 cycles together, the total duration is 935. Then we also realize that when we add the last three uh, duration, it is also 937. Why is this an important breakthrough? It's an important breakthrough that we will realize that we predicted the downward duration, even though we know the upward duration here, right? We predicted the downward duration, right? And okay, and by our prediction, we are saying that when we add together, right? We add the when we add this magnitude